Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, our fourth video on using Venn diagrams for probability. Let's start with some facts about probability I need you aware of. Pause the video and double check you can explain to me what it means for two events A and B to be mutually exclusive. Well, A and B are mutually exclusive if they cannot occur at the same time. So in a picture form is probably easiest. In this Venn diagram here, the circle in red is the event of A happening, and the circle in blue is the event for B happening. Here, there is no overlap between A and B. There is no elements in the intersection between A and B. If I had a diagram like that with some overlap, then there are some elements that are in A and B at the same time, so they wouldn't be mutually exclusive. But if they don't overlap in any way, then there is nothing in common between them, then they can't happen at the same time. And another way of phrasing it, maybe slightly more mathematical, two events A and B are mutually exclusive if their intersection is zero. So you could say the probability of A intersection with B is zero. There is no chance of A and B happening at the same time, i.e. there is no overlap, there is no probability of an event in an overlap. So that's one key idea. The next one is independence. Pause the video and double check if you remember what it means for two events A and B to be independent. Well, we said two events A and B are independent if the probability of either occurring is not affected by the other occurring. Now that was a bit of a mouthful, so we formalized that with some notation. We started off by talking about the probability of A given B. So we said A and B are independent if the probability of A happening given B has happened or will happen is just the probability of A. The probability of A is not affected by whether or not B happens at all. And similarly, the probability of B given A is just the probability of B. Now that was our formal definition. An implication of that, or something that a result we used many times about independent events. The probability of A and B occurring if A and B are independent is just the probability of A multiplied by the probability of B. And that is a key idea we're going to use throughout this particular skill. So let's get on and have a look at some Venn diagrams and answer some probability questions. So here's the first question. Pause the video and have a go. So the Venn diagram shows how 10 people travel to work. Their travel to work is represented by capital W is walking, capital T is train. State whether or not W and T are mutually exclusive. You can clearly see there is no overlap in the circles for W and T, so that means their intersection is zero. So you can state that the probability of W intersection with T is zero, therefore they are mutually exclusive. Okay, next it says one person is chosen at random. Find the probability the person walks to work. Well, there are 5 people out of a total of 10, and 5 over 10 simplifies to a half. Simple as that. Next, what's the probability the person travels by train? There are 3 such people out of a total of 10, and you can't simplify that, so we're done. Okay, next question. Pause the video, have a go. Okay, so here we're told we've got 15 people travelling to work, and they either are travelling by bicycle, train, or some combination. Part A, one person is chosen at random. Find the probability that this person travels to work by bicycle. Now, bicycle, hopefully you can see, there are 10 and 2, which is 12 options for that. Out of 15 in total, we know there are 15 people, so it's 12 out of 15. Alright, so the probability of bicycle is equal to 12 out of 15, and that simplifies, dividing top and bottom by 3, that simplifies to 4 out of 5. What's the probability they travel to work by train? Well, by train there are 2 and 3. There are 5 options out of 15, so the probability of train is 5 out of 15, and dividing top and bottom by 5 there, that simplifies to a third. What's the probability they travel to work by bike and train? So the probability of bike intersect train, well, there are 2 options in the overlap here, so it's 2 out of 15, which doesn't simplify. So probability of B intersect T, or bike and train, is 2 out of 15. Then it says state whether or not B and T are mutually exclusive. Well, B and T can't be mutually exclusive because they can happen at the same time. There are 2 out of 15 opportunities there. B, the probability of B intersect T is not equal to 0. Therefore, not mutually exclusive. Because for them to be mutually exclusive, the probability of B intersect T, or B and T, must be 0. Are they independent? Well, let's think about this. For them to be independent, we know that the probability of B and T must be equal to the probability of B multiplied by the probability of T. So let's check what the probability of B multiplied by the probability of T is, and let's see if it's equal to 2 out of 15. So let's do some work over here. The probability of B, we know, is equal to 4/5. We've done that. The probability of T, we've done that as well, is equal to 1/3. And we know that 4/5 multiplied by 1/3 will actually be 4 out of 15, which doesn't simplify. Now that is not equal to 2 out of 15. Okay, so therefore we can say they're not independent. So we can say that here the probability of B intersect T is 2 out of 15, and that is not equal to the probability of B, which is 4 out of 5 multiplied by 1 out of 3. Therefore, not independent. And the last one, given that this person chosen at random travels to work by bicycle, find the probability that it will also take the train. So we're trying to work out the probability that they take the train given that you know that they took the bicycle. Well, let's have a think about this. What's the probability they took the bicycle? We know it's these options here. There are 12 possible options there. So the probability that they took the train, given the fact you know they're in this circle anyway, there are 2 options to take the train out of a total of 12 here. So this is simply the case of saying the probability of the train, given that they are in the bicycle there, is going to be equal to 2 options out of a total of 12 on the bicycle, which actually simplifies to 1/6. Okay, and we're done. Right, next question. Okay, a very similar style question here. So we've got a Venn diagram. Capital B is bicycle, capital T is train, capital W is walk. It says state 2 events that are mutually exclusive. B and T are definitely not. They have an overlap. So you could say B and W. That would be a perfectly acceptable answer. There's no overlap between B and W. Or you could say T and W. They have no overlap. Both of those would be fine answers. It says one person is chosen at random. Find the probability that this person walks to work. Well, there are 7 people who walk to work. Out of a total of 25, you know that, and that's your answer. Find the probability that this person travels to work by bicycle and train. There are 5 such people. Out of a total of 25, dividing top and bottom by 5, you get a fifth. And then the last one, it says, given that the person chosen at random travels to work by bicycle, so you are only interested in the bicycle people here, these 9, find the probability they will also take the train. Well, 5 of them also take the train, but out of the restricted number of people who also use a bicycle, 9. So it's 5/9 and we're done. Okay, last one. Pause the video, have a go. Okay, it says the Venn diagram shows students in the class who read books A, B and C, and the Venn diagram is given. One of the students is selected at random. State 2 events that are mutually exclusive. A and B have an overlap, so they can't be. B and C have an overlap, so they can't be. But A and C have no overlap in common, so they are mutually exclusive. What is the probability the student reads more than one magazine? Well, how many students read more than one? Well, these 2 here and these 3 here, so there are 5 out of a total in the class of 4. Add 2 is 6, add 5 is 11, add 3 is 14, add 6 is 20, add 10 is 30. Dividing top and bottom by 5, you get a sixth, and we're done. Next, find the probability that a student reads A or B or both. So everything in A, this 4 and 2, and everything in B as well. So it would be the 4, add the 2 is 6, add the 5 is 11, add the 3 is equal to 14. So it's going to be 14 out of 30, which simplifies to 7/15. Next, find the probability that a student reads B and C. Well, B and C is the overlap between B and C, so it's these 3 students out of a total of 30, which simplifies dividing top and bottom by 3 to a tenth. Now, last part, given that the student, it says, remember, one student is selected at random. Now we're told a fact. Given that that student at least reads one magazine, so they are in this circle, this one, or this one, they definitely read one or more magazines. Find the probability that the student reads C. Well, in this 4 add 2 add 5 add 3 add 6 is 20. The probability that they read C is 6 add 3. There's 9 inside the circle, so it would be 9 out of 20, which does. And the last one, it says, given that the student reads at least one magazine, determine whether or not reading magazine B and reading magazine C are independent. Well, if they were, then the probability of B happening, if I found that out and multiplied it by the probability of C happening, it would certainly give me the answer for the probability of B intersection C. That is one of the conditions for independence. So we actually know this from part D. We've already worked this out. So if we get the probability of B multiplied by the probability of C and get that we got the same answer as part D, we'll know they're independent. The probability of B is 2, add 5 is 7, add 3 is 10, so it's 10 out of 30, multiplied by the probability of C, which is 3 add 6 is 9 out of 30, and if you multiply them together you get 90 out of 900, which simplifies to a tenth. Now that agrees with part D, so probability of B intersection C from part D is equal to probability of B multiplied by probability C, therefore independent. And that's it for this video. Thanks loads for watching.